However, we physicists say that the universe was created in a Big Bang 13.7 billion years ago.
Astronomers using the James Webb telescope just found a super bright galaxy that seems older than the universe.
And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
It's also racing towards us at an unbelievable speed. This mind-bending discovery has astronomers freaking out, and even world leaders are worried. What could this mean? Why is everyone so spooked? The Webb telescope challenges our cosmic understanding. The James Webb Space Telescope, or JWST, is revolutionizing our view of the cosmos, particularly its recent detection of galaxies, pushing the boundaries of what we thought possible. This article delves into the discovery of JD's GSZ-14, a galaxy defying expectations and prompting a reassessment of our understanding of early galaxy formation. JADE's GSZ-14 holds the title of the farthest confirmed galaxy, existing just 290 million years after the Big Bang. This timing is significant because the universe at that point was a mere 2% of its current age. The presence of such a massive galaxy so early in time contradicts prevailing models suggesting the early universe was dominated by gas and darkness, with minimal large-scale structures. This discovery isn't alone. JD's GSZ-13, another record-breaking galaxy found by JWST, further challenges existing theories. These findings suggest our standard cosmological models might be incomplete or even fundamentally flawed. It raises crucial questions. How could such massive galaxies exist during the so-called Dark Ages? Did galaxy formation initiate earlier or differ significantly from our current understanding? The scientific community grapples with a mix of excitement and concern. While these groundbreaking observations push the boundaries of knowledge, they necessitate revising or potentially rewriting much of current cosmology. The presence of these early galaxies throws established theories into question, demanding a reassessment of the universe's evolution. JWST's discoveries aren't just adding information, they're provoking profound questions about the universe's infancy. This continuous cycle of discovery and questioning fuels astronomical progress. As JWST delves further back in time, it promises to illuminate more details about our cosmic origins. The process of refining and updating our cosmic theories is intricate and ongoing. It involves meticulous data analysis and a constant reevaluation of what we believe we know about the cosmos. The discovery of JD's GSZ-14, so early in the universe's history, underscores how much remains unknown. It serves as a reminder that the universe is brimming with surprises, and our exploration has only just begun. Beyond JADE's GSZ-14, another distant galaxy, JD's GSZ-141 was also detected. While fitting scientific expectations better, it hasn't received as much attention. However, the stark contrast between JD's GSZ-14 and its counterparts highlights its unusual nature. What makes JD's GSZ-14 truly remarkable isn't just its immense distance, but its sheer size and luminosity. Spanning over 1,600 light-years, its brightness isn't fueled by typical processes, like gas falling into a supermassive black hole. Instead, its brilliance stems from a multitude of young stars. Researchers estimate this galaxy's mass to be several hundred million times greater than the Sun's. The formation of such a colossal luminous galaxy within a mere 300 million years poses a significant challenge. How could such a structure form so rapidly? This anomaly suggests processes contributing to galaxy formation might be different or begin earlier than previously thought. JWST's capabilities ensure that even a dimmer version of JD's GSZ-14 wouldn't have escaped detection. This suggests the possibility of even older galaxies dating back to the first 200 million years of the universe's existence. This potential for even earlier discoveries raises immense expectations regarding future JWST revelations. The existence of JD's GSZ-14 with its unexpected characteristics necessitates potential revisions to current cosmological models. Its presence during the universe's early stages implies aspects of cosmic evolution we haven't yet grasped. As these discoveries accumulate, they present a richer picture of the universe's history, but also suggest many long-held assumptions about galaxy formation might be inaccurate. Continued observations and discoveries by JWST are paramount to unlocking further understanding of the cosmos. Each new piece of data not only challenges established theories, but also expands the boundaries of what we deem possible in the universe. As more galaxies like JADA's GSZ-14 potentially emerge, the story of the universe's formation will undoubtedly grow more intricate, revealing not only the depths of the cosmos, but also the limitations of our current scientific knowledge. The JWST, serving as a window into the universe's distant past, becomes increasingly vital as we anticipate further revelations from the depths of space, a complex universe. The James Webb Space Telescope is completely revolutionizing our understanding of the early universe, particularly with the discovery of galaxies like JADA's GSZ-14. This newfound galaxy, brimming with oxygen, throws a wrench into established theories of galaxy formation and evolution. The presence of oxygen in JADA's GSZ-14, a mere 290 million years after the Big Bang, signifies a level of chemical maturity unexpected for such a young galaxy. Typically, oxygen is a byproduct of massive stars exploding as supernovae, a process thought to take much longer. So how could a galaxy develop so rapidly in such a short time frame? This discovery directly challenges the established timeline of galaxy formation. The existence of galaxies like JADA's GSZ-14 suggests a potential flaw in our current models of cosmic evolution. Galaxies of this size and brightness shouldn't exist so soon after the Big Bang, according to these models. This discrepancy presents two possibilities. Either our understanding of the universe's age is inaccurate, or our fundamental theories of galaxy formation require significant revision. The rapid development of JADA's GSZ-14 has even led some to propose radical ideas, like the existence of galaxies predating the Big Bang itself. However, this is a last resort approach when established theories fail to explain the observations. JWST isn't the first to challenge our cosmological views. Prior observations with the telescope revealed inconsistencies in the expansion rate across different parts of the universe, as well as a non-uniform distribution of matter. These discoveries already questioned the core principles of cosmology. Now, the presence of JADA's GSZ-14 adds another layer of complexity. Each discovery seems to chip away at our current understanding of how the universe functions. The implications are profound. Our existing models for galaxy formation and evolution might be based on incomplete or inaccurate interpretations of the early universe. As more data floods in from JWST and other sources, the scientific community may need to brace itself for a complete overhaul of our understanding of cosmic history. This ongoing challenge isn't just about tweaking a few parameters. It could lead to a fundamental shift in our view of the universe. Astronomers and cosmologists are actively grappling with these anomalies, testing new theories and models to better explain the complexities of galaxy formation and the early universe. One such theory, proposed by Nobel laureate Roger Penrose, suggests a cyclical universe. Conformal cyclic cosmology presents a scenario where our universe is just the latest in a long chain, each beginning with a Big Bang. This theory proposes a never-ending series of universes, raising questions about the initial spark and the possibility of a timeless cosmic existence. Additionally, recent research explores the concept of multiple universes. A 2023 paper proposes that our universe's expansion might be due to merging with others, similar to soap bubbles joining forces. This merging could explain the observed faster-than-predicted expansion. Studies by John Ambjorn delve further, suggesting that the unexplained dark energy could be a consequence of merging with smaller emerging universes. This concept aligns with some of the unusual phenomena observed by JWST, such as inconsistent expansion rates and rapid galaxy formation. Despite these intriguing theories and JWST's groundbreaking observations, a definitive model explaining all aspects of the universe's structure and behavior remains elusive. Each new theory adds complexity, introducing more hypotheses to be tested and explored. As we delve deeper into the cosmos, the picture becomes more intricate, filled with unknowns demanding elaborate explanations. The challenge lies in constructing a unified model that encompasses all observed phenomena, providing a clear understanding of the universe's vast and intricate nature. The development of the James Webb Telescope.
The Webb telescope is a reflecting telescope. technically an astigmatic telescope.
The James Webb Space Telescope marks a new era in space exploration. This marvel of engineering, a collaborative effort between space agencies, pushes the boundaries of human ingenuity. Originally envisioned in the 1990s, JWST was designed to surpass its predecessor, the Hubble Space Telescope, by operating in the infrared spectrum. This allows it to pierce through cosmic dust clouds, revealing previously unseen celestial wonders. JWST boasts a massive 21.3-foot main mirror, composed of 18 hexagonal segments coated in gold-plated beryllium. This large mirror gathers more light, enabling observations of fainter and more distant objects than Hubble ever could. Protecting this delicate instrument is a sun shield, the size of a tennis court. This crucial component shields the telescope from the sun's heat, which would disrupt its observations. The 5-layered sun shield dramatically reduces heat by over 1 million times, creating a frigid environment necessary for the telescope's instruments to function. Beyond its impressive technology, JWST embodies the scientific community's insatiable curiosity about the universe. It carries the legacy of James E. Webb, a former NASA administrator who championed space exploration. This ambitious project promises groundbreaking discoveries, forever changing our understanding of the cosmos. Launched on Christmas Day 2021, JWST took 30 days to reach its designated position, the second Lagrange point, nearly 1.5 million kilometers from Earth. This strategic location allows the telescope to maintain a stable alignment with Earth while orbiting the Sun, crucial for uninterrupted observations. JWST's deployment was a complex multi-stage process. First, the sun shield was meticulously unfurled, followed by the secondary mirror and the intricate assembly of the 18-segment primary mirror. Precise alignment of these segments, taking months to refine, was paramount. Only a perfectly aligned mirror system could capture sharp, detailed images of deep space. Equipped with cutting-edge instruments like the near-infrared camera and spectrograph, JWST is designed for high-resolution imaging and spectroscopy. These tools are essential for capturing detailed visuals and spectral data of distant galaxies, star clusters, and other celestial objects. By observing the universe with unprecedented clarity, JWST furnishes scientists with invaluable data to decipher the cosmos's secrets. JWST's ambitious goals include exploring the origins of stars and planets, tracing the evolution of galaxies over billions of years, and identifying environments conducive to life beyond Earth. A key objective is to study the first galaxies formed after the Big Bang, believed to hold the key to understanding the universe's early development. In July 2022, JWST delivered its first set of full-color images, showcasing groundbreaking depth and clarity. These images revealed remote galaxies, regions of active star formation, and various cosmic phenomena in exquisite detail. This initial glimpse confirmed JWST's capabilities and hinted at the wealth of scientific discoveries yet to come. The James Webb Space Telescope signifies a paradigm shift in our ability to study the universe. Its groundbreaking design and technology have set new standards for space telescopes. Overcoming hurdles like budget strains and technical difficulties, a global team of experts from NASA, ESA, and CSA successfully launched and now operates the James Webb Space Telescope. This international collaboration highlights the power of unity in space exploration. The telescope beams back valuable data, aiding astronomers worldwide in uncovering the universe's secrets. From alien planets to the building blocks of life, Webb's observations hold vast scientific potential. By offering a sharper, deeper view of the cosmos and peering further back in time, it broadens our understanding of the universe and our place within it, igniting scientific exploration for years to come. As Webb unveils more celestial secrets, the awe-inspiring patterns of galaxies and stars come into sharper focus. What Webb revealed. The James Webb Space Telescope has become a game-changer in our understanding of the universe. One of its triumphs is capturing an image of the distant planet HIP 65426b, a behemoth exceeding Jupiter's mass by 6 to 8 times. This planet resides a staggering 100 times farther from its star than Earth is from the Sun. Imaging planets at such distances is challenging because starlight tends to drown them out. To overcome this, JWST utilizes a sophisticated tool that blocks the star's glare, enabling a clear view of the planet. Additionally, JWST has shed light on the universe's expansion by studying Cepheid variable stars, aiding scientists in their quest to understand the Hubble constant. This constant is crucial in determining the universe's expansion rate. While JWST's data hasn't conclusively settled the ongoing debate about the exact rate, it has highlighted discrepancies between various measurement methods, prompting further investigation. JWST has also peered into the nascent stages of supermassive black holes within young galaxies. It captured light emitted from galaxies formed less than 1 billion years after the Big Bang, revealing how black holes grow colossal over time. Understanding black hole development is vital for comprehending how galaxies evolve over billions of years. In another groundbreaking discovery, JWST detected complex organic molecules, akin to those found in Earth's oil and coal, in a remarkably old galaxy, over 12 billion years old. These molecules are believed to be attached to dust particles in space. This finding offers valuable insights into early universe chemical processes and potentially the formation of life-essential elements. JWST's ability to see through cosmic dust has unveiled intricate details within stellar nurseries. One of its most captivating images depicts the Carina Nebula, also known as the Cosmic Cliffs, a vast gas and dust cloud some 7,500 light-years away, brimming with new star formation. These detailed observations provide a clearer picture of the processes by which stars are born, revealing the conditions that favor their creation. These contributions by JWST are pivotal in expanding our knowledge of the universe. The data and images it provides not only improve our understanding of distant planets, star formation, and black hole growth, but also push the boundaries of human knowledge about the cosmos. Each discovery deepens our understanding and prompts new questions, ensuring the continued evolution and growth of astronomy. JWST has captured high-resolution images of supernova remnants, like Cassiopeia A, one of the most studied remnants in the universe. Its observations revealed previously unknown details within its inner structure, including clusters of gas and dust likely to evolve into stars and planetary systems in the future. Furthermore, JWST has extensively analyzed exoplanet atmospheres, providing richer insights into their composition. When observing the gas giant WASP-39b, similar in mass to Saturn but with a closer orbit to its star, the telescope detected water vapor, sulfur dioxide, carbon monoxide, sodium, and potassium in its atmosphere. Such discoveries are crucial for understanding the chemical dynamics at play in exoplanet atmospheres, enhancing our knowledge of how these environments function. JWST has also made strides in exploring distant cosmic phenomena, like the discovery of Sears 1019, a galaxy harboring the most distant active supermassive black hole ever observed. Notably, this black hole is smaller in mass compared to others previously identified from the early universe. Detecting such a black hole offers fresh insights into how these colossal entities form and evolve over time, significantly contributing to our understanding of cosmic development. Additionally, the telescope has studied the Wolf-Rayet star WR140, nearing the end of its life and exhibiting a unique pattern of concentric rings. This pattern is created by the interaction between the star and a smaller companion. Observations like these are crucial for understanding the processes that occur in the later stages of massive stars' lives, shedding light on the complex life cycles of these celestial bodies. In its examination of distant galaxies, JWST captured revealing images of the Phantom Galaxy, showcasing previously invisible heat-emitting structures of dust and gas. The ability to see such details helps astronomers locate star-forming regions and accurately measure the masses and ages of star clusters within these galaxies. The James Webb Space Telescope's contributions span numerous aspects of space exploration, significantly deepening our comprehension of the universe's history and the development of galaxies, stars, and planetary systems. Through groundbreaking observations and data collection, JWST refines existing theories while sparking new questions, fueling the engine of discovery. Each piece of information adds a vital piece to the cosmic puzzle, offering a clearer view of the intricate mechanisms governing the birth and evolution of celestial bodies across the vast expanse. This ongoing exploration is fundamental to piecing together the grand narrative of the universe, revealing how we came to be and how the universe itself has unfolded. Space, with its vast unknowns, ignites our curiosity and compels us to delve deeper. Among the most captivating mysteries are dark matter and dark energy, phenomena that continue to baffle scientists and astronomy enthusiasts alike. Dark matter, estimated to constitute roughly 25% of the universe, remains invisible to our instruments. Its presence is inferred through the gravitational pull it exerts on visible matter, like galaxies in motion. Despite extensive research, its true nature remains elusive. Some theories propose it's composed of unknown subatomic particles fundamentally different from visible matter. Dark energy, another significant enigma, makes up around 70% of the universe and is believed to be the driving force behind the universe's accelerating expansion. Understanding its precise nature is a crucial scientific pursuit, influencing the ultimate fate of the universe, eternal expansion, or a catastrophic collapse. Pulsars, rapidly spinning neutron stars that emit beams of radiation, hold another layer of intrigue. Since their discovery in 1967, these cosmic lighthouses have been observed pulsing with remarkable consistency. However, the mechanisms behind their pulsing and occasional glitches remain shrouded in mystery. Research suggests magnetic fields and currents might play a role, but more investigation is needed to paint a complete picture. The Moon's own magnetic field presents another puzzle. Only specific regions exhibit magnetism, possibly remnants of an ancient asteroid impact, or the cumulative effect of smaller, more recent ones. This selective magnetism is still being unraveled, with multiple theories vying for explanation. Another intriguing enigma is the unexpectedly low amount of lithium observed in the universe compared to theoretical predictions. Some scientists believe this lithium might be hidden within the hearts of stars, shielded from our telescopes. Others posit the existence of hypothetical particles like axions, which might have absorbed protons, hindering lithium creation shortly after the Big Bang. The process of star formation within galaxies like our Milky Way also presents intriguing questions. The observed rate of star formation appears too high considering the available visible matter. Recent observations suggest that expelled gas from galaxies may eventually return, replenishing the fuel for star formation. This recycling of material could explain how galaxies maintain their star-making capabilities over vast stretches of time. The quest for extraterrestrial life remains a prominent area of scientific inquiry and public fascination. Despite extensive searches for signals from intelligent civilizations, no definitive evidence has been found. However, the discovery of exoplanets with potentially life-supporting conditions has rekindled the flame of hope. Current and future space missions are dedicated to exploring whether life exists beyond Earth. The ultimate fate of the universe is a profound and complex question with several possible outcomes. One scenario depicts an ever-expanding universe, ultimately becoming cold and desolate. Another foretells a potential collapse known as the Big Crunch. Unraveling the mysteries of dark energy is key to these predictions. Gamma-ray bursts, the most powerful explosions observed in the universe, releasing enormous amounts of energy in a short time, are another area of active research. Believed to be triggered by the collapse of massive stars or mergers of neutron stars, their precise origins and mechanisms require further confirmation through observations. The distribution of matter throughout the universe is another puzzle. Observations suggest a significant portion of baryonic matter, the building blocks of stars and planets, remains unaccounted for. This missing matter is theorized to reside in the warm, hot intergalactic medium, a hot, diffuse gas lingering between galaxies. Detecting and studying this matter could provide invaluable insights into the universe's development and structure. As JWST continues its groundbreaking exploration, we can expect even more captivating discoveries that will reshape our understanding of the cosmos and our place within it. Each celestial mystery unraveled paves the way for new questions, propelling us further on this extraordinary journey of cosmic exploration. So what are some other cool things captured by this legendary telescope? More wonders revealed by Webb. Peering back to the dawn of time, JWST captured the faint light emitted by galaxies just a few 100 million years after the Big Bang, These baby galaxies offer invaluable insights into the universe's early formation and evolution. Analyzing their composition allows scientists to understand how the first stars and black holes emerged and how galaxies began to take shape. The cosmic reef. Webb's infrared vision revealed a stunning image nicknamed the Cosmic Reef, a colossal star-forming region within the Carina Nebula. This image showcases towering pillars of gas and dust sculpted by stellar winds and radiation, where new stars are cradled within the nebula's swirling embrace. This detailed view helps scientists understand the intricate processes of starbirth and the conditions that favor stellar formation. Water vapor. On a rocky world, JWST detected water vapor in the atmosphere of the exoplanet LHS 1721b, a rocky world about twice the size of Earth, located 11 light-years away. This discovery is particularly exciting because LHS 1721b resides within the habitable zone of its star, a region where liquid water could potentially exist on the surface. Studying the planet's atmosphere further could reveal clues about its habitability. A chemical cocktail on WASP-39b. Observations of the gas giant WASP-39b revealed a complex cocktail of molecules in its atmosphere, including water vapor, carbon dioxide, sodium, potassium, and even hints of sulfur compounds. Studying the chemistry of exoplanet atmospheres helps us understand the diversity of planetary systems and the potential for life beyond Earth. Supermassive black holes in disguise. JWST's infrared vision revealed a population of supermassive black holes hidden within dusty galaxies. These black holes are shrouded in dust, making them invisible in visible light observations. However, Webb's ability to detect infrared emissions allows scientists to identify these obscure giants and understand their role in galaxy evolution. A black hole's growth spurt. Webb captured observations of a quasar, a galaxy with an incredibly active supermassive black hole at its center. The data suggests that this black hole is rapidly devouring surrounding matter, growing at an astonishing rate. Studying such quasars helps scientists understand how black holes feed and evolve over time. A ring. Around a distant galaxy. Webb revealed a stunning image of a distant galaxy with a prominent ring structure. This ring, formed by dust and gas, may be the result of a past collision with another galaxy. Studying such galactic collisions helps us understand how galaxies evolve and interact with each other over vast timescales. A new look at Jupiter's atmosphere. While not strictly beyond our galaxy, Webb's observations of Jupiter provided a unique perspective. Its infrared vision revealed the complex atmospheric dynamics of the giant planet, including swirling storms, auroras, and temperature variations. These observations offer new insights into the composition and behavior of Jupiter's atmosphere. These are just a few examples of the many incredible discoveries made by the James Webb Space Telescope. As it continues its mission, we can expect even more astonishing revelations about the universe, pushing the boundaries of our knowledge and igniting our curiosity about the cosmos. Isn't the James Webb Telescope one of the most fascinating things ever created by man?
Cosmic giants in the Orion Nebula. The galaxies that look like 6 bright red dots in space are some of the oldest and largest galaxies we've ever seen, dating back nearly 13.3 billion years. These galaxies formed just a few hundred million years after the Big Bang, which is much faster than we thought possible. Until now, experts believed that it took much longer for such massive cosmic structures to develop. But here they are, already enormous and full of new stars shortly after the universe's birth. One of these galaxies is especially surprising. It's 1 trillion times more massive than our Sun, and 10 times larger than the Milky Way. This immense size and mass so early in the universe's history suggests that the so-called dark ages of the cosmos might have been more active and bright than we once thought. But that's not all. Astronomers are also looking at an exoplanet named K218b, which might have the right conditions for life. The James Webb Space Telescope found water vapor in its atmosphere and detected molecules like methane and carbon dioxide. These molecules, along with a hydrogen-rich atmosphere and possible water oceans, make it a good candidate for life. Even more interesting, they found dimethyl sulfide, a compound usually produced by living organisms on Earth, hinting that this exoplanet could indeed support life. Expanding our knowledge further, astronomers have also found a remarkable alignment of galaxies. Just 830 million years after the Big Bang, 10 galaxies were found lined up like beads on a string. This surprising discovery gives us a visual snapshot of our universe's early days and challenges our current ideas about how galaxies form and arrange themselves. These findings by the James Webb Space Telescope are changing how we see the universe. Each discovery not only adds to our cosmic story, but also changes what we know about the universe's origins and early development. The implications are huge, suggesting that the universe's earliest periods were far more dynamic and complex than we previously thought. But this isn't the end of the surprises. With each new discovery, we are reminded of how little we know and how much there is still to learn. The universe continues to amaze us, pushing the boundaries of our knowledge and inspiring a sense of wonder. The cosmic structure we're talking about spans over 3 million light-years and is centered around a super bright quasar, a galaxy with a massive black hole at its core. This fascinating line of galaxies might eventually form a giant galaxy cluster, similar to the well-known Coma cluster. In the early universe, supermassive black holes already existed. These massive cosmic objects grow by absorbing nearby stars, gas, and dust. The James Webb Space Telescope has shown us these huge black holes from the universe's early days, capturing images from when they had just started devouring their surroundings. Interestingly, it has also seen the farthest black hole ever detected in X-rays, located in a galaxy named UHZ-1. This black hole is an incredible 13.2 billion light-years away from Earth, so we see it as it was just 470 million years after the Big Bang. Its mass is estimated to be between 10 million and 100 million times that of our Sun, which is amazing considering this is like the combined mass of all the stars in its galaxy. Let's dive deeper into space to see more wonders beyond our solar system. The luminous edge of the Horsehead Nebula. Closer to us, the Horsehead Nebula, or Barnard 33, is about 1,300 light-years away from Earth. With the James Webb Telescope, astronomers have been able to see the small-scale structures at the lit-up edge of this nebula for the first time. The nebula shines because of light from a nearby hot star, even though it formed from a collapsing interstellar cloud. While the surrounding gas clouds have mostly scattered, its famous pillar-like shape remains due to denser material. However, it's estimated to last only another 5 million years before it starts to fade. These advanced observations help astronomers understand how dust particles are pushed away from the cloud by UV light, creating intricate patterns in space. Then, there's the aftermath of a supernova in the constellation of Copia, about 11,000 light-years away, which exploded around 3,140 years ago. The remnants are still visible, fascinating astronomers with the warm dust crucial for planet formation and the birth of life. This dust, made of heavy elements like sulfur, oxygen, argon, and neon, was expelled during the supernova. It glows in beautiful orange and pink colors, giving us a rare look into the building blocks of the universe. In the vastness of space, tiny fragments cut through the gas, looking like cosmic bullet holes. This isn't just a cool visual, it's also important scientifically. We see something called light echoes, which happen when light from a supernova is absorbed and then re-emitted as infrared light by nearby cosmic material. Far away in the Serpent's Nebula, about 1,300 light-years from Earth, there's a huge area where new stars are born. NASA's James Webb Space Telescope has spotted some fascinating things here. One of the discoveries is jets of gas from young stars, which are uniquely aligned in a way we've never seen before. Another interesting find is the Bat Shadow, a planet-forming disk that looks like a flapping bat. In our Milky Way galaxy, the telescope's near-infrared camera has given us the clearest image yet of the Sagittarius A** region. This area is about 300 light-years from the galaxy's supermassive black hole. The image shows about 500,000 stars and some strange, needle-like structures in ionized hydrogen that don't fit with current astronomical theories. There's also a cluster of young stars still forming, adding more mystery to the list of celestial wonders. In the Orion Nebula, around 1,350 light-years away, a new type of celestial body called jumbos has been found. These are free-floating planetary mass binary systems, meaning they are pairs of objects with masses ranging from 0.6 to 14 times that of Jupiter. They aren't tied to any star and drift freely in space. Astronomers used the Carl G. Jansky Very Large Array to study one of these systems, known as Jumbo 24, using radio waves. This shows how modern astronomy is revealing amazing new details about our universe. We picked up steady signals from both parts of a binary star system, This was surprising because big stars usually don't form or stay in pairs. It's amazing to think about the huge forces at play in keeping such a pair together in the vastness of space. The focus then shifted to the complex process of star formation. Scientists have always found it hard to study how stars are born because these events happen in thick clouds of gas and dust that block visible light. But the James Webb telescope changed everything. It can see infrared light, which goes through these dusty clouds, letting us see details of star formation we never saw before. Our space journey now shows us how stars are born and evolve, the dance of gas and stars in Rho Ophiuchi. For example, the Rho Ophiuchi cloud complex, only 390 light-years away, has been observed in great detail. The telescope captured a frozen moment of a stellar explosion, showing around 50 young stars, many of which are about the same size as our Sun. Without the James Webb telescope, these stars would have stayed hidden, like looking at a blank black picture. The telescope also found dozens of young, small stars shooting out fast streams of gas and particles. These streams light up the surrounding hydrogen clouds, giving us more clues about how stars form. Then there's the Ring Nebula, or M57, located in the Lyra constellation about 2,500 light-years away. The James Webb telescope gave us amazing new details. It showed that the ring has about 20,000 clumps of molecular hydrogen, and the inside is full of superhot gas. The nebula's main shell has a thin ring of carbon-based molecules called polycyclic aromatic hydrocarbons, which make it glow beautifully. Astronomers also found 10 rings outside the main ring of the nebula. They think these rings were made by a dying star's gas interacting with a smaller companion star. As the smaller star moved through the gas, it created ripples, showing us how dynamic and lively these celestial features are. In 2023, a groundbreaking discovery was made, a distant galaxy named Jade's GSA 14. This galaxy is notable not just for its distance, but also for its unexpected brightness. Usually, galaxies this far away aren't so bright, making this discovery very important for our understanding of the universe. This galaxy pushes the limits of what we know about the structure and formation of galaxies at the edge of the observable universe. GSZ 130 came into being about 320 million years after the Big Bang. This galaxy, however, existed even before that, spanning a vast 1,600 light-years across. The light we see from it isn't due to a supermassive black hole, but shines brightly because of young stars. This galaxy has a mass several hundred million times that of our Sun. Plus, the presence of oxygen in its light shows that many massive stars have lived and died long before we ever noticed this cosmic giant. In another part of the universe, scientists found a new planet called TOI 7115b, located 137 light-years away. This planet might be a good candidate for supporting life. It orbits a red dwarf, a smaller and cooler star than our Sun, often surrounded by rocky planets. Its position around its star places it in the habitable zone, where liquid water, a key ingredient for life, might exist. TOI 7115b completes its orbit every 19 days, much faster than Earth's orbit around the Sun. This quick orbit makes it easier for astronomers to study and increases the chances of finding similar planets nearby. Next is the discovery of the ghostly jellyfish in a galaxy cluster known as Able 2877. This cosmic jellyfish spans over 1 million light-years and is visible only in a narrow band of radio light. Scientists think it might be a radio phoenix, bright at standard FM frequencies, but disappearing at 200 megahertz. It's the largest structure seen in this specific frequency range. It likely formed due to a massive cosmic explosion, like a black hole outburst, which fades over millions of years. Another big cosmic event, such as a galaxy collision, can reignite it, causing it to light up brilliantly in specific radio frequencies, while vanishing in others. Within the beautiful views of the Orion Nebula, scientists using the James Webb Space Telescope made another amazing discovery, a new carbon compound called methylation. This is the first time this molecule has been found in space, opening up new ways to understand cosmic chemistry and the building blocks of life beyond Earth. Next, we explore strange new worlds and surprising space phenomena, echoes of life in the Orion Nebula. In the vastness of space, about 1,350 light-years away in the Orion Nebula, astronomers found something interesting in a young star system called DD 2356. This compound is important for creating more complex carbon-based molecules, which are essential for the beginning of life. Despite the strong UV radiation from nearby young stars, which usually destroys complex organic molecules, this harsh light might actually be helping to create methylation. This process could be a key step in forming even more complex carbon structures, hinting at the possibility of life in such tough conditions. On the dwarf planet Ceres, located in the asteroid belt between Mars and Jupiter, there's a volcano that doesn't fit the usual fiery image, called Ahuna Mons. This volcano is an icy marvel, erupting with cold materials like ice and salts instead of lava. This is especially surprising because Ceres was once thought to be geologically dead. Ahuna Mons is a cryovolcano, a rare type that erupts with cold stuff. This kind of volcano isn't unique to Ceres. It's also found on other moons in our solar system, like Enceladus, Europa, and Triton, adding a fascinating twist to planetary geology. In another part of space, Comet Lovejoy presents a sight that seems almost too strange to be real. When it came closest to the Sun in January 2015, it wasn't just water that the comet was releasing. Scientists were surprised to discover that Lovejoy was also releasing a lot of alcohol, about 20 tons of water per second. This discovery made Comet Lovejoy not just one of the brightest and most active comets seen recently, but also a floating source of cosmic spirits. When looking deeper into the findings from the Orion Nebula, researchers noticed that the formation of complex molecules was happening in ways they hadn't expected. Despite the odds, life-supporting compounds were forming in a place bombarded with harsh radiation, making scientists rethink how life might start elsewhere in the universe. On Ceres, the presence of cryovolcanoes suggests that there might be more geological activity on dwarf planets and moons than previously thought. The icy eruptions of Ahuna Mons imply that there could be subsurface oceans or reservoirs of liquid beneath the icy surface, which could potentially harbor life. Comet Lovejoy's alcohol emissions open up new questions about the chemical processes that occur in comets. The presence of alcohol and other organic molecules suggests that comets might play a crucial role in delivering the ingredients for life to other parts of the solar system. The discovery in the Orion Nebula shows that even in the most unexpected and harsh environments, the building blocks of life can form. This challenges our understanding of where and how life might exist beyond Earth. Ceres and its cryovolcano, Ahuna Mons, remind us that even small and seemingly inactive worlds can hold surprises. The potential for subsurface oceans on Ceres adds a new dimension to the search for extraterrestrial life. Comet Lovejoy's unexpected alcohol release makes scientists wonder what other secrets comets hold. These celestial bodies could be key to understanding the origins of life in our solar system and beyond. At its peak, a comet threw out materials, including alcohol, into space with such force that it was like throwing out 500 bottles of wine every second. This strange event isn't just interesting for wine lovers. It suggests that comets might have brought important ingredients for life to Earth. In the middle of our Milky Way galaxy, there's a huge natural particle accelerator that sends out beams of charged particles, called cosmic rays, almost as fast as the speed of light. But recent studies have found something surprising. Despite all the activity, many of these cosmic rays are somehow stopped from entering the center of the galaxy. Scientists think this might be because of complex magnetic fields around the supermassive black hole at the galaxy's center, known as Sagittarius A. As we go further, we find places where life might start, surrounded by familiar shapes. PDS-70's water discovery. Elsewhere in space, the James Webb Space Telescope made a big discovery around a young star system called PDS-70, which is in the middle of forming planets. This star system, which is only 5.4 million years old, has water vapor, a key element for making rocky planets like Earth. The water vapor, heated to about 330 degrees Celsius, was found not far from the star. This suggests that water could be forming in the star system itself, or coming from icy dust particles that heat up and turn into vapor as they move closer to the star. This discovery means that any planets forming in the system could have water from the start, creating a good environment for life. In a fun but important observation, astronomers have seen a nebula in the Large Magellanic Cloud, a galaxy about 163,000 light-years away, that looks a lot like the video game character, Pac-Man. This nebula, called N63A, is the result of a star exploding. The nebula's shape, which looks like Pac-Man, surrounds newly formed stars that look like the dots Pac-Man chases in the game. Despite its playful look, N63A is a young nebula that could potentially form new stars as it changes, giving scientists more information about the life cycle of stars and the dynamic processes in galaxies. In space, about 1,300 light-years away from Earth, there is an amazing star system called GW Orionis. This system is special because it has a planet that orbits not one, not two, but 3 stars at the same time. Picture a giant target in space, surrounded by 3 dusty rings. In the middle of this target, 3 stars are at the center. 2 stars are closely orbiting each other, while the third star moves around them in a wider circle. Scientists have been watching the system closely and noticed that the rings are slightly tilted. They think this could mean there is a huge planet, about the size of Jupiter, hidden in these rings. If they are right, it would be the first planet ever found to orbit 3 stars. Closer to us, just 11 light-years away, is another fascinating world called Ross 128b. This planet, which is a bit bigger than Earth, orbits the star Ross 128. What makes Ross 128b so interesting is that it's in the habitable zone of its star, where conditions might allow liquid water to exist. Liquid water is important because it's essential for life as we know it. The star Ross 128 is smaller and cooler than our Sun, which might make Ross 128b a good place for life. Scientists think that even though Ross 128b gets more sunlight than Earth, it could still have a similar climate, possibly with clouds high up in its atmosphere reflecting some of the extra light. How do these findings change your view of the universe's mysteries? Do they make you more curious or skeptical about our cosmic origins? Don't forget to leave your thoughts in the comments, and subscribe for more.